This is an experiment to establish bidirectional communication between two LoRaWAN network with node MCU, ESP8266. The components required for this experiment are two LoRaWAN chips we need, and one node MCU, one micro USB cable, one cable for one LoRaWAN chip and other one for another LoRaWAN chip, and two node MCU, one as transmitter and another one is a receiver, and one LED, and either a desktop or laptop, some jumper wires, and Arduino IDE software. So the LoRaWAN module is used to connect with the node MCU ESP8266. This is the circuit diagram for doing connection with the node MCU. So I'll explain you how to do the connection. Then the complete program explanation I have done in another video, and the link is shared in the description box. So if you want to know the meaning of each and every statement used in this program, you can see that video. This experiment requires two LoRaWAN module. The module number, it is displayed here, you can see RA01 V3.2 2393. So one act as transmitter and another one as a receiver, and vice versa. Now both the devices are trans receiver. So I have explained how to connect LoRaWAN module with your node MCU. RA01 V3.2 LoRaWAN module. It has got the frequency 2393 megahertz. So RA01 is a popular LoRa trans receiver module. It enables long range wireless communication using LoRaWAN modulation technique. The frequency 2393 megahertz is the operating frequency of this particular module. To communicate with this RA01 LoRaWAN module, you will need to use appropriate LoRa library for your node MCU, that is microcontroller platform. So depending on the microcontroller you choose, whether Arduino board or node MCU, ESP8266, you will need to find the library that supports your hardware. LoRa module operates at different frequencies, but the frequency mentioned on this module is 2393 megahertz. So it is a relatively specific, and it may not be the standard frequency band for LoRa communication. And it is important to ensure that the frequency you are using is allowed in your region, and that you configure the module frequency settings correctly. So you can see the antenna here. This is antenna for both modules. Antenna is there. You can check here. So the LoRa module will require an appropriate antenna for efficient communication. Ensure that you connect the correct type of antenna and position it properly for optimal performance. Remember that LoRa technology requires proper configuration and often involves two or more devices communicating with each other using this LoRa modulation. Each device needs to be configured with the same frequency. So this is 2393 megahertz, and the other module should also have the same frequency, 2393 megahertz. Each device needs to be configured with the same frequency, and the other settings to establish a successful communication. This is the way of connecting node MCU ESP8266 with your LoRaWAN module. The ground pin of LoRaWAN module should be connected to ground pin of node MCU. And this side also LoRaWAN module has got one more ground pin. Ground pin of LoRaWAN module is connected to ground pin of ESP8266. This is one important connection. Then 3.3 volts of LoRaWAN module is connected to 3.3 volts of ESP8266. And it has got two pins, RES and DI00. These two pins should be connected to, RES pin is connected to D0 and DI00 pin is connected to D2 pin of node MCU. And this side, there is NSS pin. This pin is connected to D8 pin of node MCU. MOSI, master out, slave in. This pin is connected to D7 pin of node MCU. And master in, slave out, MISO pin. This pin is connected to MISO, that is master in, slave out. This pin is connected to D6 pin of node MCU. And SCK, serial clock. Serial clock of LoRaWAN is connected to D5 pin of node MCU. So, and ground pin of node MCU is connected to ground pin of LoRaWAN. Two ground pin this side and one ground pin this side. So if this much connection we should do before using the LoRaWAN module, using LoRaWAN communication technology. As I explained the connection diagram here, the same connection is done here. This is connected to the node MCU. See, it is connected to node MCU. In the same pattern, one more node MCU with one more LoRaWAN module. So we need two node MCU and two LoRaWAN module to make one as transmitter and one as receiver. The same connection I have done on both the sides. And connect micro USB cable to one of the node MCU and another micro USB cable to another node MCU. Connect this micro USB cable to the USB port of one laptop and another micro USB cable, this gray color, it is connected to another laptop. So in this experiment, I am using two laptops, one node MCU and one LoRaWAN module to one laptop, and another node MCU and another LoRaWAN module to another laptop. So two laptops, two transmitter, one as transmitter and another one is a receiver. In order to check the data whether it is transmitting or not, I am using two LEDs here. So for one microcontroller, to the D4 pin, anode of the LED is connected and cathode of the LED is connected to ground pin of node MCU. See here, anode is connected to D4 pin of node MCU and cathode is connected to ground pin. In the same fashion, other side, the anode is connected to D4 pin of this node MCU, and cathode is connected to ground pin of this node MCU. So in order to check the communication properly. Now I'll show you how the communication takes place. So you just connect the LoRa module and check the COM port properly selected or not. So I have selected the COM port 3 in this laptop because it is connected to laptop COM port 3. And in this laptop, in the second laptop also, you have to check the COM port whether it is selected properly or not. and check the board also. The board selected must be Node MC 1.0 ESP12E model in both the cases. Check the board and check the port. Only this much you have to do. Now you open the serial monitor here. Open the serial monitor, and in this laptop also I'll show you that laptop. Here also you open the serial monitor, and the most important thing, you check the baud rate, and the baud rate must be 115200. This computer. Here also the same baud rate you should select, 115200. After checking all these conditions, whether port is selected properly or not, board is selected properly or not, and node MC is connected properly or not, whether the baud rate is selected properly or not, and whether you have opened the serial monitor or not. All this, after taking all these precautions, in serial monitor, you just type hi. I'll type here. Okay, I typed hi. So when I press enter, that hi, you should see it on the second computer. I'll press now, hi. So it is sending a message, sending message hi. Okay, so this is transmitter now. Now in other laptop, we'll check whether we have received hi or not. Now you check here, the message received is hi. This is acting as a receiver. Now I'll send hello from this laptop. Okay, so I have typed hello and I'll just press enter. So what message it will see? You see sending message hello here. So it is sending a message hello, because now this computer is acting as a transmitter. So we'll go and check in that laptop whether hello is received or not. Now I got the message. The message received is hello. There I sent hello. Here I received hello. In the previous example, here I sent hi. There I received hi. So in this case, in this way, both the laptop are communicating with each other using this LoRa technology. So now I have kept my laptop in a very small distance, approximately 20 to 25 centimeters. Now, if you take your laptop far away from this first laptop, then also you can send the message. You can do the communication. And one more thing I want to show. Since I have connected LED to both the node MCU, when I send message in this computer hi, and for 2 seconds, the LED which is connected to this node MCU turns off, and again it will turn on. Okay, I'll show you that. Now again I'll go and type hi here, or I'll type Shanta, my name. Okay, I'll type Shanta. Before pressing, you just check the condition of the LED. I'll show you here. I'll keep this here so that you can check. Now I have typed Shanta. I'll just press enter from the keyboard. You check the status of the LED. When it is transmitting the data for 2 seconds of time, the LED turns off. Again, it will turn on, because we have written program in that case, like that only. Now I'll press enter. For 2 seconds, it is off, and again it is turned on. So when it becomes turned on, by that time, the data is sent to the second computer. Okay, this is first computer. Now I'll show you in the second computer. Now in this computer, I'll send my name Mukartihal, MUKARTIHAL. So I have typed my name Mukartihal, and when I press enter, this LED will turn off for 2 seconds. By that time, the data is sent to the first computer, and once the data is sent, it will turn on once again. See, you can check the message. Just now I sent message Shanta from that computer. The message received is Shanta. Now I am sending Mukartir from this computer, and you check the status of the LED, and we'll go and check in the computer. I'll press enter now. See, LED is turned off for 2 seconds of time delay. After that, it is turned on. The message sending message is Mukarti heard, and at the same time, you check the message. So the message received is Mukarti heard. So in this way, you can do the communication between devices. The distance may be it is used mainly for a long distance communication. Since for experimentation purpose, the distance I have used is 20 to 30 centimeters. That's it. So you can change the distance and check whether the communication is taking place or not. So in this way, you can check the communication using LoRaWAN module.